Interest Group meeting. And we are going to be recording the session today. Some ground rules. This is your session. It's a chance to have your questions answered and your opinions heard. If you have questions, comments, or opinions, speak up. We would love you to put your questions in the chat. And we are going to ask the questions at the end. I'll introduce myself. I'm Christina Rappa. I'm the Material Interest Group Chair for AATCC and one of your hosts today. Our other host is Apurva. Would you like to introduce yourself?
Yes, absolutely. Hi, guys. I'm Apurva. I am the member at large for the Materials Interest Group at AATCC, and I'm excited to be here.
Okay, and our next slide. All right, here we go. Introduction to our honored speaker today. Daniela Rodinone. She is a representative from Biophilica. And Daniela graduated from a bachelor's in textiles and apparel design from Palermo University in Argentina in 2014, where she specialized in women's wear, tailoring techniques, and textile experimentation. Upon graduation, she was the first ever Argentinian apparel designer to be the recipient of the Fulbright Scholarship in Science and Technology. This allowed her to pursue a Master's of Textiles and Science at North Carolina State University, where she focused on different areas of technical textiles, such as biomaterials, smart textiles, and textile comfort. Today, she is the Business and Operations Manager at Biophilica, a London-based startup dedicated to the manufacturing of leather-based alternative materials. As part of this role, Daniela brings her expertise in technical textiles. In addition, she manages relationships with external luxury and mainstream brands that are interested in using the company's leather alternatives. She also manages the R&D projects. Throughout her career, Daniela has written over 15 academic publications and participated as a speaker and exhibitor at more than 14 international conferences. So we're really excited to welcome Daniela today to the Material Interest Group session, and we're going to turn it over to you.
Thank you, Christina, for the introduction, and thank you for inviting me to present here today. I'll be sharing my screen. Do you all see my screen? It's loading.
Yep.
Yeah, perfect. Well, again, thank you for the invite. Today, I'm going to be introducing everybody into the world of leather alternatives and also presenting Trikind, which is Biophilica's leather alternative. In today's presentation, I'm going to be covering different topics. First, I'm going to give an introduction into what leather alternatives are. Then I'm going to be introducing Trikind by Biophilica, which is a plastic-free leather alternative, going over the key properties and also going over how it's produced. Then I'm going to be covering testing leather alternatives, what's the importance and what are the different approaches. I'm going to cover as well material certifications. I feel that for this type of materials, it's really important to talk about the different claims that are made and the importance in certifying these new innovations. Then, as an example, I'm going to provide a case study of a collaboration we did with ID Genève watches as an example of how these materials can be introduced into the market. And then I'm going to wrap up with conclusions on the key highlights from the presentation. These slides will be posted after the meeting. And then, as Christina mentioned, if anybody has any questions, you can put them in the chat. I will be happy to answer those. So first, to start, a quick overview of Biophilica. Some of you might or might not know the company. We are a London-based company. This company was founded by Mira Nameth. She's the founder and CEO in 2019. She comes from a creative director experience in the US, and this innovation was done as part of her master's in the UK. Biophilica is a B2B company, which means that we provide the material to the different brands that use our material Trikine into the manufacture of different products, from belts to footwear, bags, watch straps, and many other products. Biophilica consists of a full-time multidisciplinary team of 12 team members, and in addition to this, there's consultants and different advisors. We are located in London in a 300 square meter facility. We moved there around 2023. And the first product of the company is Trikine, which is a plastic-free leather alternative. And this was followed in 2023 with a 100% bio-based adhesive. I'm going to be talking more about that later in the presentation. And in terms of investment, Biophilica has both private and public investment. Mira did a really good job in getting different UK grants, and we also have different sources of private investments, such as the one from Rhapsody Ventures. So first, I'm going to do an introduction into leather alternatives. And really, before talking about leather alternatives, we need to start by talking about leather. Leather is a material that we are all familiar with. It has been around us for centuries. And as a material, it has quite impressive properties. It is bio-based and biodegradable. It has really good properties when we think about strength, elasticity, durability, and resistance to abrasion. It also has a really nice hand touch and feel, and that's why it has been used for many luxury products. But at the same time, it has a lot of flexibility, which means it can also be used for example, sportswear, outdoors, and many different products. However, there are some disadvantages associated to this material. The first one being that it comes from animal origin, and this is not in line with some of the current sustainability goals and the desires from brands and consumers. Another disadvantage is that typically it has a high price. All depends on the quality, of course, but talking about general terms. And from a product development point of view, if we analyze the image, that's from a leather hide. Typically, it has a really lack of uniformity across the surface, associated to the fact that this comes from an actual animal, and if there's any insects or any bugs that damage the skin, then this will be showcased into the final product. So typically when working with leather, there's a really huge effort in placing the patterns in such a way that you would only use the good parts, which means that you end up with a lot of waste. And the irregular shape that leather has across the borders and the variation in thickness makes this even more challenging. And then typically for leather, you use a lot of resources, mainly for the tanning and dyeing processes. There's a high use of water and energy. Keeping these disadvantages in mind, decades ago, synthetic leather came onto the scene as a lower cost material that would simulate the touch and feel of leather, but that it would be of lower cost. And this is thanks to the manufacturing techniques that are used for producing things like PU or PVC. This is typically manufactured in continuous, typically roll-to-roll machinery, and this brings costs down significantly. This also means that it's possible to achieve a more uniform surface with a more regular shape. This comes typically in rolls of 1.5 or even 3 meters wide. It's also possible to easily modify the surface, the thickness, and the color by, for example, changing the pigments that are used. Of course, this doesn't have any animal origin most of the times. However, there's still disadvantages with this material. The main one being that it's fossil-based, and therefore it's not biodegradable. There's also concerns about the plastic release from this material, and it has been found to be less resistant than leather in some of the applications. With these things in mind, the cons of both synthetic leather and natural leather, it's where leather alternatives came into play. The first attempts into creating these materials started around 2013. And the goal was to imitate the look and feel of leather, but at the same time being animal-free and using minimal amounts of plastic for having improved biodegradability. So in these materials, typically the advantages are that they are usually from natural origin. I'm saying oftentimes because there's many players in this market by now, and not all of them use natural origins, but it's really common for you to see leather alternatives made from banana waste, apple, and different types of feedstock. The same goes for the biodegradability. Most of the times, brands that develop leather alternatives try to use either 0% or really minimal amounts of plastic to improve biodegradability. These materials have a lot of flexibility to meet different applications, and they have a uniform and regular shape. So in a way, they attempt to use similar methods of production as you would find in synthetic leather, but using natural ingredients. Of course, there's still some disadvantages associated to them. The main one being that they are relatively new in the market. 10 years is not that long for a new material, and most of the times they are not fully scaled up yet. And another point that I'm going to touch on later is that there's no tailored standards for evaluating them. But a lot of good efforts have been made, and in the upcoming years, all these disadvantages can be highly improved. In here, we can see an overview of these leather alternatives. This is from a report from Material Innovation Initiative. They develop really good reports in this area, and you can see a general overview of some of the options of inputs of materials that are typically used across this range of products. As I was saying, some of the inputs can be plant-based. It could be sources of waste from different feedstock, but it could also be input from microbiology and fermentation activities, or from cell and tissue engineering. And most of the times, it typically involves creating some sort of natural formulation that will then be laminated onto a textile backing. Of course, this is just to summarize, but each company will have a more complex process. So I'm going to be presenting Trikyne by Biophilica and talk about how we approach this leather alternative. Here we see some of the unique benefits of Trikyne. When Trikyne was created, the ultimate goal was to create a material that would be completely free of plastic. So the first step for creating this was to have a plant-based material. This material is made from lignocellulosic feedstocks. The first iterations of the material were done using leaves and stems from London parks, autumn leaves. And later on, we started introducing other inputs to have more variety. And we use, for example, inedible agricultural feedstocks. Some examples of that can be sweet corn, broccoli, tomato, and from those productions, we don't use any parts that could be used for human consumption. So it's mainly the stems and the leaves. The fact that we use this type of input and that we combine it with other natural ingredients means that we can achieve a material that's completely free of plastic, and this makes the material also circular and compostable. And overall, we like to claim that we use low resources. We have LCAs and other more detailed studies underway for the current iterations of materials. So we want to be cautious with the claims we do. But just to give an example, considering the fact that our material doesn't need to go through a tanning and dyeing process as you would have with leather, means that you save a lot in terms of water and energy required to produce the material when you compare it to natural leather. In terms of compliance and testing, we test our material with the standards that are typically used for leather. We use ISO standards. I'm gonna give some examples later in the presentation. And the innovation is patented to protect this innovation. This happened since April 2023. And at the bottom, you can see some of the options of colors that we currently offer for the material, but we develop custom colors as well for different customers. In here, I'm going to talk about the layers of trichine in more detail, because in order to achieve a circular material and to have a biodegradable leather alternative, special attention needs to be placed in every single layer. So in order to achieve a material, as you would see in the picture on the slide, you really need to pay attention to every single layer. The layer that we call trichine would be the layer that has the feedstock and the different natural ingredients. That layer is extruded onto a conveyor belt, and when it's dry, it's laminated onto a textile backing using a bioadhesive. Depending on the application and the customer needs, sometimes we apply biocoating as well, made from natural ingredients, to achieve different functionality. So looking into the trichine layer in more detail, as I was saying earlier, the key input for that layer is the feedstock. We have different sources of that, and if we see in the picture with the Petri dishes, we receive the feedstock in our London facility in a bigger size, as we see in the image, and then that feedstock goes in-house through a process of grinding up to a specific particle size, depending on the characteristics of the formulation that we need. So typically then take the form of something more similar to a powder. That feedstock is then mixed with plant-derived binders and plasticizers and different natural pigments. Because this is proprietary information from the company, I cannot disclose all the ingredients that go into making trichine, but I thought of giving an example. So, for example, for producing black trichine, we use algae black pigment from living ink. And I would say for these new materials, that's a key thing, to collaborate with other startups and other innovators that are producing bio-based materials that we can use as part of our formulation. Moving on to the adhesive layer, for this, we developed our own adhesive. This emerged after months of trying to find a bioadhesive in the market that would be used for the material, and we couldn't find good alternatives that would be 100% bio-based. So we decided to develop our own adhesive, and this is what we use to laminate the trichyne onto the textile. We have seen such good results with this adhesive, and we have seen so much interest from brands that were looking for adhesives maybe for the manufacture of their products, that we decided last year to launch this as a separate product. So we still use the adhesive for manufacturing trichyne, but we are also starting to offer it as a standalone product for using it onto different substrates and for using it onto manufacture. So we are currently conducting manufacturing trials, and this will be available in the upcoming months. And lastly, talking about the textile backing, we wanted to continue with the same philosophy that we applied onto the other layers. We wanted to make sure that the textile backing was 100% natural to ensure this biodegradability. We don't produce the textiles ourselves, which means that we try to engage with trusted partners to get this material, and when possible, we source certified textiles with certifications like Oecotex, for example, or similar certifications that would ensure the contents and that would ensure the quality of what we are getting. Typically, we use woven materials. So, for example, we have used 100% cotton or 100% tencel, and the thickness and the exact type of weave depends on the final suppleness that we want to achieve on the material. So in here we can see an overview of the evolution of the material production from trichyne, and I'm looking into other players in the market. Most leather alternatives are following the same evolution. When Biophilica was created, the production would happen by mixing all the ingredients and pouring that trichyne paste into small trays. The output of this would be A4 sheets, and this was mainly as a proof of concept and to be able to do the first material testing. But of course, this needed to be improved in order to provide material to brands. That's why between 2021 and 2022, we moved on to a production method where we would pour this mixture, but onto bigger trays. And that wasn't the only improvement. It wasn't only the size, but also the fact that the trays would be prepared with a textile backing under tension. So it would be the textile backing under tension, and then the trichyne poured manually onto each tray. This would allow to have sheets of 35 centimeters by 70 centimeters. And the big jump for us really came when we moved on to the new facility, the one where we currently working. And as part of that, we set up a semi-continuous extrusion line that allows us to extrude trichyne onto a conveyor belt that runs. And with this method, we let the sheets dry, and then they are laminated onto a textile backing. This not only allows us to have bigger sheets, so in this case it's roughly 40 centimeters by 2.5 meters, but also it added more uniformity on the material, considering that with the pouring method that was a very manual task, the semi-continuous extrusion really brings more uniformity and also the possibility of better tuning the thickness of the material. Of course, we are already looking into what's next, and the key next step would be to move on to a continuous factory production. It would be similar to the production of PU or PVC, but of course without the plastic components. And for that, we are currently conducting trials to test out the machinery. So the key challenge is to find the proper machinery that works with our formulation, that doesn't have the same characteristics as a formulation for PU or PVC. And the goal for that would be to have an output of rolls of 3 kinds that would be 1.5 meters wide, and really increase the demand in terms of the output in terms of meters produced. In here, you can see in these pictures a snapshot of what the current semi-continuous production looks like. As you can see in the close-up image, the material is extruded onto a conveyor belt. And with this, we also introduced another benefit, which is the use of casting papers. So we work with different casting paper suppliers, and the 3 kind is directly extruded onto casting papers that have a texture, which means that when you peel off the material, you can obtain textures as you see in the image on the right. And this is a really good option that different customers might find attractive for their products, and also gives a lot of flexibility. There's many different patterns to choose from. So it's another way of providing a different product. Talking about some of the design features, manufacturability has been a really key aspect of this journey. And the way we work is by working with brands that want to use our material in their products. And as part of that, we engage in processes where we do different prototyping, and they test the material in different workshops. Typically for leather products, a lot of the manufacturing would happen in Italy, in Portugal, and in Asia as well. But for the early stages, it's for smaller quantities, mainly Italy. And we have seen really good craftsmanship applied to our material, as you can see in those watch straps. Watch straps have been the first application we embarked onto, and then moving on to bags, belts, and other types of leather goods. And then further down in the pipeline, we would be looking into more complex applications such as automotive or furniture. We engaged in an R&D project with an automotive company, and we want to continue exploring that area. In terms of some of the options from a design point of view, we have done different trials, and we saw really good results when doing embossing in the material. As you can see in the picture, embossing allows to have a deeper texture when you compare it to casting paper, but both are available options depending on the product and the brand aesthetic. And then we also saw really good results when using laser etching. In here, we can see some product examples. And one key thing from this, if we look at the first example, that's a concept bag that was done by Bean, which is a bag company from London. if we look at that specific product, we can see that it's a quite shiny aesthetic, and that's one of the key things about our material and our company. We would engage with each brand and try to meet their specific design requirements. So there's a lot of flexibility in the look and feel and the suppleness that can be achieved with our material. The other image on the right, it's a bag that was developed as part of a competition that Hype, a bag brand from the UK, did. And this was really interesting for us because it was a competition that aimed to encourage young kids into pursuing STEM fields. So the fact that in our company we have different designers, engineers, and scientists working together, we thought it was a really good cause to support. So those were the key properties of TreeKind. Now moving on to the testing of leather alternatives. This is a key area that I'm interested in covering. Thinking about the fact that we are a B2B company means that we need to work really closely with the different brands that want to use our products. And what we end up doing is a combination of testing at the material level and then testing at the product level. Both are really important in order to have the best possible product in the market. When talking about material level testing, when we moved to the facility we are currently in, we developed a testing suite where we can have different testing equipment, such as flex testing, tensile testing, scratch testing, and other categories. And that allows us to do a really short iteration cycle. So when we develop a new formulation, we can know right away if it will be suitable for different applications. So that has been really good for us. Depending on the brand that we are working with, we oftentimes also do third-party testing with external laboratories. And all of this material testing needs to be combined with testing at the product level. Testing at the product level, it's mainly managed by the brand, so they would do prototypes and run their own testing, whether that's with brand consumers or with in-house or external testing laboratories. And that's really key for ensuring that the product manufactured with our material would be durable and it would sustain daily use, for example. Depending on the brand we work with and on the timelines and capabilities, sometimes it's challenging to have detailed feedback from those processes. So for that reason, since last year, we started conducting our own trials, manufacturing trials, to have a better understanding of the effect of stitching and of different manufacturing techniques on our material. So that's something we are working in. In here, we can see some examples. It's routine testing that we do, and the different categories are quite standard for the industry. I would say a quick comment on this. For example, flexing testing, that's really important for footwear applications. So that's an area we pay close attention, and that allows to simulate how our material would react when being used on a shoe with the movement on the foot, for example. So that's an area that you can do repetitive testing. And then another important area to mention is seam strength. So that's a type of testing that we introduced last year, and that has been really interesting because it allows to have an intermediate result, kind of an intermediate step between material and product testing. You would stitch two pieces of trichyne together, and you can get a lot of information about the type of thread and the overall performance of the material when being stitched onto layers, and have an approximation on how it would react on the final product. In here, we can see some of the results from testing we conducted for Fashion for Good brands. You can see the different categories of testing, and the way we typically approach testing is by having different requirements for different applications, and then we see how our material matches each of those targets. What we use as reference is the requirements set out by Eurofins, and then we work towards the different applications. As I was mentioning, we started with watch straps, and now moving on to handbags, leather goods, footwear, and moving on to the applications that will have higher and higher requirements. As we can see, overall, our material has been performing really good. And I thought of including a more visual example. This is this is a key advantage of our material. The fact that we apply the pigment onto the formulation of trichyne, and the fact that the material would come out of the line with the color that it will have in the end, means that there's barely any transfer, and we can see how well it performs when comparing it to a leather sample, in this case Napa leather. So that's something we do quite frequently, testing materials in the market and see how our material compares to that. This is another example of testing we conduct. In this case, it's about chemical analysis. So this is not something we do that frequently. It's more testing we do to show brands that the things that our material doesn't contain. To protect our innovation, we need to be really cautious in disclosing the actual ingredients that go into producing trichyne, which is why sometimes it's challenging to communicate with brands, because we cannot disclose all the information. So by using chemical analysis, LCAs, and other types of testing and certifications, we can give peace of mind to brands that our material doesn't contain any harmful substances, any plastic, or any of the undesired components. So in this case, we kind of knew this would be the outcome, but you always need testing to prove certain things and to give peace of mind to brands. And something similar with composting. We already knew the ingredients that we put in our formulation, but again, biodegradability testing ensures that the final material will in fact be biodegradable. And one comment or one question we sometimes receive from brands is they are concerned that if the material is biodegradable, means that if you have a bag made of trichyne, you would be walking on the street, and if it rains, it will disintegrate or something like that. And we always assure brands that it's biodegradable only when it is in certain conditions, in soil with certain microorganisms. So The fact that it's biodegradable doesn't mean that it won't be durable. But again, this shows those properties as well. So now moving on to material certifications. This is an area I thought it was important to cover, to give an overview of some of the certifications that are applicable to leather alternatives. In the world of sustainability and leather alternatives, there's a lot of claims that are made and a lot of terms that are used sometimes in the wrong way. So for these materials, it's really important to understand what is being claimed and what the material does or doesn't have. The first one being PETA. What that certification shows is the fact that raw materials are free from any animal-derived ingredients. That's a certification we currently have. And then moving on to USDA, that's a certification that's really important as well for leather alternatives, because that will refer more to the different percentages of plastic that might be used in layers. That's the case sometimes with some leather alternatives. So with this certification, what's the focus is the bio-based content of a product. I put that image as an example. It says product 100, but not all the time that's the percentage. And by USDA, bio-based, they defined it as derived from plants and other renewable materials. So again, for leather alternatives and for claims being made, this is a really important one. And both USDA and OECOTEX are certifications that, as part of the process, include third-party testing. So everything is very transparent and ensures the transparency of the final material. Another important one is OECOTEX. In that case, it specifically focuses on harmful chemicals. So by getting that certification, you need to test each single component of the product. An interesting thing about this one is the fact that this is something we would be interested in achieving in the future. And for that, there would be a benefit if we use OECOTEX certified textile backing. Means that you then don't need to test that material because it already has a certification. So having this knowledge becomes really important for us when selecting the materials. Every single material we use, any ingredient, any layer we apply needs to be in line with these things. And then there's other category of certifications more at the company level. So B Corp, most of you might be familiar with that. That certification talks about companies meeting high standards of social and environmental performance, transparency and accountability. So that really talks about the company as a whole, the type of team members that are working there, the work conditions, and it's a really broad and good one for sustainability, but it doesn't necessarily focus solely on the material itself. It's more at the company level, similar with ISO 9001. That's a certification on quality management systems. And thinking about these leather alternatives that are going into a journey of being scaled up and being placed into factories, this will become really important in the future because it will ensure that there's a consistent quality that customers receive in the products and services. So that becomes important when thinking about high levels of materials. For startups and new or next-gen materials, this is a journey that will be slightly slower. For certifications, you typically need dedicated teams, and they cost money and efforts, but if we are talking about materials that have a lot of sustainability claims, it's really important that in the coming years, leather alternatives start to get these certifications. And lastly, to in a way wrap up what I covered before, I wanted to present a case study. We have a lot of collaborations in the pipeline with different brands, but we have a lot of NDAs with most of them. So this is one that's already launched in the market that I can talk about. It's a case study of a collaboration with ID Genève watches. So ID Genève watches, it's a luxury company from Switzerland. It's a very interesting company that is aligned with what we are trying to achieve. And for us, that's usually key when selecting the partners we engage with. It's not necessarily about the size of the company or how known the brand is. It's that helps, of course, but it has to be a company that has our same mission in terms of sustainability and the use of materials. ID Genève watches, it's a company that intends to use circular components throughout the whole product. So that applies to the metals they use for any single component that they use on the watches they produce and sell. They were instantly attracted by our material for the biodegradability claims, and we engaged with them in what ended up roughly a 2-year project, where we developed a custom material for them. They had some specific requirements, both in terms of the final aesthetic, so the look and feel they were trying to achieve, but also they have specific requirements in terms of performance. So this was a really interesting experience for us. As part of this, we developed different iterations of a custom material. We did in-house testing. We also conducted third-party laboratory testing in laboratories they wanted to engage with. And then we had a lot of rounds of prototyping. And with those prototypes, they would also do product level testing. So in terms of watch straps, it would be torsion testing, for example, to simulate how the watch strap would behave when being used by the customer. So in this case, it's a really good example of the whole process of developing a new material, engaging with the brand, and then as a result of this, launching a product on the market. In here, we can see the results of that. And if you remember an example I showed earlier in the presentation from the bag for Bin London, you can see that the material in this watch strap looks completely different. It's not that shiny, smooth material. It's more matte material, and it also has some marks. So they wanted to go for this design with different speckles as part of a design decision, and we supported them on that. And this limited collection was launched, and if you go into their website, you can select our material as one of the options for watch straps. So we are really happy with the results and overall the craftsmanship that they used for watch straps, which helps a lot in launching a successful product. And this was an added benefit. So last year they announced that Leonardo DiCaprio is investing in the company, and as part of that, we were able to get this picture of Leonardo using the watch with our material. So it was a really good experience from R&D point of view, and then a business and marketing experience. So to wrap up and provide some key highlights or conclusions on this, After this presentation, it becomes clear that leather alternatives provide a suitable and innovative option for natural and biodegradable materials. These materials have been now in the market for more than 10 years, and at this moment there's a lot of options using different formulations, different layer combinations, and that gives a lot of options in terms of suppleness and in terms of overall characteristics of materials that could be used for different products. Also to keep in mind the scale-up efforts. So currently there's a really high demand from both luxury brands all the way to more mainstream brands to use these leather alternatives. So these current scale-up efforts that Biophilica is doing and that other brands in the market are doing will really help in meeting this demand in coming years. And on the area of things that need a little bit more work or improvement, it becomes clear that there's a need for developing new test methods that are specifically targeted to these next-gen materials to do a more fair comparison and set up specific lists of requirements. And also, as these brands in the market become more established and have more years of experience and have bigger teams, material and company certifications will really become key indicators for the transparency and the quality of these leather alternatives. Probably most of the leather alternative brands won't be able to disclose the ingredients they use, but there needs to be more transparency into the biodegradability and different sustainability claims that are done. And before finishing, I want to introduce you to the whole team of Biophilica that makes this possible. We have a great team with really good expertise across engineering, science, chemistry, and all the different areas that you really need to develop these unique materials. We have team members working more closely in R&D in the lab, and we have other team members dedicated to production, to business communication activities. So really, as with any startup, a lot of hats to cover, but this team is making it possible to have a really good material. And to wrap up, I would be happy to answer any questions now. And if you come up with things later on, you can always email us. And yeah, either with questions about the company or questions from the presentation, or we could go over any questions now.
Yes,
maybe.
Yeah.
Sure.
We actually have quite a few questions in the chat. So Apurva and I will moderate the questions. Please add your questions as you come up with them, and we will field them to Daniela. So the first question is that different leathers have a variety of hand feel and flexibility. And can Biophilica be engineered to be soft and flexible or thick and sturdy?
Yes, it can. And we engaged in different R&D projects with different brands, and by changing the ingredients that are used, without disclosing too much information, but basically by changing the ingredients that are used, the particle size, and the textile backing, I would say those are the key things that would have an impact on the final suppleness. Also, the quantity of adhesive that's being used, the thickness of that, all of that impacts and makes the material more suitable for watch straps or bags. For example, for watch straps, some companies prefer the material without the backing and the adhesive because they have other materials they use as inserts, so they don't need the textile backing, and that allows them to have an easier manufacturing process. So it really depends, but there's a lot of flexibility in that.
Great. The next question is Biophilica tree kind traceable? There are a few different companies that make bio leather. What makes tree kind stand out?
So the traceability, it is traceable. We are currently conducting an LCA, and as part of that, we had to provide really detailed information about the suppliers we use, every single thing, where does it come from, how does it travel to us. So we typically provide those reports to brands we have or companies we have NDAs with, but we have full transparency ourselves in where each item comes from. And then the other question was, how do we stand out? Our way of standing out has always been the fact that we don't use any plastics. It's really tempting, or it could be an option to have a natural material, but then apply a coating of PU on the top, and that would make life way easier for a lot of the functionality properties. And we decided to go through a more difficult route, but that means having improved biodegradability. So that's our key selling point.
So you talked a little bit about how the tree kind polymer is laid onto a release paper and then applied to a textile using a lamination process with adhesive. Can the material also be cast directly onto a textile? More similar to like wet processing synthetic leather?
We use that type of process when we were using the tray method. So it is an option. The way we approach that meant that you would have good addition with the textile backing, but it was a very manual process. So the tree kind layer at the top wouldn't be that uniform, but I'm sure there's other technologies that we will explore in the coming months that give that. It's mainly working closely with machinery suppliers and doing the trials and adapting their machinery to the requirements of our formulation.
The next question is tree kind certified bio-based product under USAID bio preferred? Is that?
I think it's USDA.
Yeah, I figured. I didn't want to assume it's USDA. Under USDA bio preferred, is that fully biodegradable?
It is fully biodegradable. It's not certified by USDA yet. We are in the process. The first certification we opted for was the pizza vegan, and we are in conversations, and we started the process with USDA and Oecotex, but we are currently conducting the third-party testing, so it will take a little longer. Yeah, certifications take a lot of efforts, and as a small team, that take a little longer, but that's the plan.
So you talked a little bit about PETA vegan certification. How does tree kind differentiate itself from traditional synthetic leather, which is also often marketed as vegan leather? Does the customer know the difference yet between regular and bio-based synthetic leather?
I don't think so. So if you only consider, that's why I covered all the certifications. If you only look into PETA, we would be in equal terms. So it would be synthetic and alternative leathers or tree kind the same. And obviously animal leather won't have that certification. So that's why we want to have a range of certifications, because it's not only, I mean, PETA vegan certification is great, but we also have the no use of plastic and the biodegradability. That's where we have an added bonus. But I think that if you only look at PETA, only for that one, it would be the same, pretty sure.
Okay. The next question is, have any washability tests been performed with an eye on using tree kind in garments in the future?
Not yet. Garments, it's an interesting one that we at the moment decided to stay away from. If you use a material for a garment, you need to think about a user using the garment, sweating, and there's a lot of other components that would be more complex. So we currently don't engage in any products for garments. The same applies to outdoors or more technical applications. For now, we try to stay within leather goods, watches, bags, and products like that. We would love to do that in the future, but for now, we are not pursuing that.
Can you talk a little bit about the textile backings that you've used for tree kind? For example, have knits been used, and can you get stretch tree kind? And do you source cotton fabrics with GOTS certifications? So organic cotton?
Yeah, we have a supplier, a really good supplier that we use that provided cotton with GOTS certification. So when possible, we try to prioritize those. In terms of knits, we try them. Unfortunately, at smaller scale, since it's not a fully continuous process, and it's like semi-continuous or even the tray method, it's really hard to have a consistent tension for knitted fabric. So in the trials we did, we wouldn't have full benefits of those materials in using them on a demo line, but it's something we want to try again once we have a factory set up and we are able to control better the tension. At the moment, using fabrics without stretch make things easier, but we are looking into some knitted fabrics that we think would provide potential. In the attempts we did internally in smaller samples, the data we got show that woven materials provided stronger and more durable samples as compared to knitted, but I think that if we try it again in the future with more scale-up machinery, it would be a different story probably.
Okay. Then there's another question from Kenneth. As a longtime leather chemist, 30 years, I'm curious about the wetting properties. Can you make it waterproof like footwear? Also, can it withstand heat like the lasting process in footwear manufacture?
So in terms of water resistance, depending on the coating you use, we mainly, without disclosing the ingredients, we have used a lot of waxes and things like that, natural ingredients. You can improve the water resistance, but it's something we want to further improve. So for those reasons, at this moment, we are not targeting the material that much for outdoor applications. In terms of the other question was on the manufacture of footwear and lasting. Our material, being a natural material, doesn't have the same heat resistance as you would have with with leather, for example. So that's also an area where we are working with footwear manufacturers to identify the best manufacturing machinery and the best processes that would be compatible with our material.
Leather has very good water vapor transmission properties. How does tree kind compare?
That I don't think that's an area we tested yet, mainly because of we are currently not offering the material for applications where that's the key requirement. We typically base the testing we do on the requirements that brands bring, but that's also an area that we would be interested in further testing as we develop more technical applications.
Awesome. Looks like we have one more question. What is the best way to get connected and start a project with Biophilica?
So it would be emailing hello@biophilica.co.uk. Yeah, and we take it from there, or emailing me. But yeah, we are always keen on engaging in either projects where we sell the material or R&D projects as well. Yeah.
I think that's an excellent question to end on. Thank you so much, Daniela, for the presentation today and for introducing your new product, TreeKind by Biophilica. We appreciate your time today, and also everyone's time in joining the webinar today for AATCC. And I just want to turn it over to Maria. Do we have any last-minute slides on upcoming events?
Yes, ma'am. Hang on a second.
And also, while you're pulling that up, I just want to mention this presentation will be available, as well as the recording, on our AATCC committee's website. So be sure to check it out there. Okay, upcoming AATCC events. We have a virtual webinar on March 6th on AI in textile discovery. We are also going to be at the Functional Fabric Fair in Portland, Oregon, April 17th and 18th. So be sure to meet up with AATCC there. We have a PFAS conference down in Raleigh, North Carolina, May 2nd through 3rd, where you can register online on the aatcc.org website. And lastly, our Textile Discovery Summit. This year will be in Savannah, Georgia, October 6th through 8th. We encourage everyone to come out to that. It's going to be a great event this year, and it's going to be an extended event into the weekend where we'll have activities. So invite your family, your kids. It's going to be a great conference this year. With that, I am going to wrap up. Oh, here we go. More questions. Of course, you can always reach out to the AATCC staff, Maria, Erica, and Diana. And we thank you all for joining our webinar today.
Thank you, everyone.
Thanks, and have a great day.
Thank
Bye.
you. Bye. Thank you.